Hello class, this is section 5.1, and in this video I just want to introduce you to the notation that we are going to use in the next couple of weeks. So we are going to deal with matrix valued functions and vector valued functions in chapter 5. So first of all, when you see a little arrow sign on top of an x, this refers to a vector valued function. So this means that we have an array of n functions that all depend on t, arranged like a vector. So in the book, you would have a boldface x, but it's obviously really hard for me to write boldface on the board and in this video. So for the videos, I'm going to have a little arrow on top of the x. So this is what a vector valued function will look like. Sometimes we'll have a matrix valued function too. This just means that we have a little, I would normally write it like this in a very straight line m. This would mean simply that we have matrices, matrix terms arranged in this way: m11t, m21t, mn1t, be commas in between, m1rt, m2rt, so on. This mn1, mn2, m12, m22, and here would be mnrt. So typically, the notation is to have the row first, and then the column. So this is the first row, rth column. This is second row, second column. This is first row, second column. The rows count first row, second row, third row from the top, and the columns count from first column, second column, third column from left to right. Oh, and the book writes this down instead as a boldface m. I can't do that right. You get a picture. It's a boldface m in the book, but I'm going to write it down as a straight line m that way. We often have to think about taking derivatives of vectors or of matrices, and in this instance, the derivative of a matrix valued function is written either this way or in the d/dt notation. You can also see it written down in this form, which just means that this is what all the entries look like. And it's really straightforward. You just take the derivative of every term. I'm not going to belabor all this writing, but you get a picture. We also write sometimes that vectors have derivatives, and that works similarly. So we have x prime, x2 prime, and xn prime. Just take every derivative in every component. So we often want to write down systems of differential equations in terms of these matrices. So when we have a system of differential equations look like this, here x1, x2, x3, xn are all functions that depend on t, and these are on the left are the derivatives. So I didn't write the t dependence on each of the x's because my hands got tired, but you get the gist of it. You have this really, really complicated system of differential equations, and it's nice to be able to use the matrix notation to simplify things a bit, and we can write what is called the coefficient matrix of this system of linear equations. So we get PT is just going to be Pij t, or the matrix that is formed by all the coefficients here. So we have P11t, P21t, and so on I'm just going to write the corners because I'm lazy. So you have this n by n matrix like so. So if we write x as simply x1 to xn, again these are all depending on t, I just didn't bother to write down the t dependence there. If you write f as f1t to fnt, then we can simply write down this really long system in this form. Which encapsulates and captures a lot of this information. So the first thing you have to learn in this section is how to translate a linear equation of this form into a matrix. And we'll go through an example in the next video.